wondering what the signs of that.
Yeah, I'm actually questioning the students to see if they're open-minded. Would you consider yourself open-minded?
Sure, yeah.
Yeah, right. How open-minded from 1 to 10 would you say you are?
I'd say 8 or a 9.
Okay, that's really good. That's way above average. So let's say you were tricked into believing a lie that affected your entire existence. Would you want to know about it, or would you rather continue just believing the lie and living in ignorance?
Probably want to know about
Right? You will want to know, right? So the real reason I'm doing this is because, do you believe the earth is a ball?
I'm literally...
No, yeah, no worries, man. Here, you could take my, I mean, if you want to go ahead and give it a toss. So this is the reason why I'm here. Do you believe the earth is a ball?
Yeah.
In outer space? So this is an official NASA image from 2012, and they admit that they don't take real photographs of the earth. So they admit this is a composite. So all the images that they show us, they're not photographs, they're CGI. You know what CGI is, right?
Yeah.
It's a computer-generated image. So if I was to ask you, why do you think a real photograph of the earth as a ball doesn't exist?
I mean, I think that it does exist personally.
Well, NASA admits that they don't. I mean, you could go to their website. That's my point. It's not even up for debate. So that's why I'm asking, why do you think that is? So they have an excuse.
I feel like, I mean, okay, so wait, what is their supposed excuse?
So their excuse is they can't go high enough. So they can't leave the Earth's the radioactive belt, right? I don't know what they call it exactly. So basically they can leave low Earth orbit. That's their excuse. But supposedly they went to the moon in 1972. So obviously, I don't know if you've heard in my opinion, the moon landing was just how would you call it? Like a setup? How would you call it? Like studio setup, basically. Hollywood trickery, I would say.
Why so?
So, because they want people to believe that we live somewhere we don't.
No, why do you believe that?
Well, because it comes back to control, basically. So they could control someone's mind, they could control someone's actions, right? So it's all about gaining people's trust, so that you basically do what you're told by these so-called superiors or intellects that are above you. So if I was to show you a very simple experiment that a child can understand to debunk this globe using physics, basically a physics experiment, would you be open to that?
Yeah, wait, sorry, but going back to what you said before, I'm just wondering, what would be the motivation, or
Well, I always say the motive comes after the understanding of the lie. So once you know there's a crime, now you start looking for a motive, right?
Or no, what would the motive, it just seems, I don't know, the idea that, because it's not just NASA, right? It's
right.
Internationally, different space agencies across the world.
And I would say
all colluding, even though there was a space race, between
Russia,
two different superpowers.
Yeah, exactly.
So you're saying they were colluding too?
Exactly. So if I was to ask you, so going back to the globe real quick, just because I know we're jumping ahead to the motives of the globe, right? So there is a very simple experiment, elementary physics, that debunks this claim. And how we know that is because NASA claim, again, they have to have satellites orbiting this Earth, right? So they need to know the radius of orbit. So they need to know the radius of the Earth if they're supposedly going around it, right? Which they do claim. So they do tell us the radius of the Earth. It's 3,959 miles, which means there has to be curvature every mile, and every mile it has to increase because they're claiming it's a curve, not a slope. Right? So every mile that dip has to keep increasing to basically make a ball. So in the first mile there's an 8-inch drop, second mile 32 inches, and by the third mile there should be 6 feet of measurable curvature. So if we went out to a giant body of water, like a lake, to physically measure the surface of water, they're trying to tell us that surface of water is bending 6 feet in 3 miles and increasing more and more and more. But we understand the physics of water. When it's contained and at rest, the surface always finds its level being horizontal.
I mean, I myself am not an expert in this, but I feel like this is an over-exaggeration of what...
Obviously, 3 miles is not to scale right here. I can't feed 3 miles into a piece of paper, but the measurements should be there. So if the surface of the water is 5 feet from the level structure, that curvature, the water should deviate 6 feet in 3 miles. So what's 6 feet plus 5?
No, I get that, but
11. So it's pretty basic math and basic physics based on the curvature formula. Obviously,
the thing is that you're under the assumption that this is truth.
This is what they tell us. This is what they're claiming they're doing because they're supposedly going around the Earth. So they could claim it's double the size. Curvature should still be measurable, but the fact is, physics, the surface of water doesn't have the ability to hump or bend. It's one of the physical properties of water.
Wait, but water does have that. For example, if you were to pour water up to the brim in a glass,
that only
you would
happens.
see surface tension, no?
Exactly. That only happens on a very small scale. But when we're talking about like a pool or even a lake or an ocean, that curvature that you're talking about wouldn't make a wall. But I do understand surface tension, which is a very small scale.
And then, I mean, okay, so I myself, I'm not like the greatest with math, so I can't like refute or
Right.
claim to understand this, but like, I'm just going back to the original thing of like, just based on, I don't know, logical reasoning, it would be almost like, I don't know, would you consider it rational to say that every scientist that's ever worked on a project, every like proponent of like NASA, or every engineer that's built anything, or like using instruments to measure, like the entire scientific community, which is hundreds of thousands, actually millions, if not tens of millions of people across the globe, are all in collusion?
Okay, so for example, NASA, I would say everybody that works for NASA, especially at mission control, they don't have to be in on the line. They're just being fed information through a computer. The astronauts are definitely lying. So you don't need 1,000 or 1,000,000 people lying. You only need a very few, like astronauts that are very top, to lie to the rest of them. So,
but the thing is, like, if it's not just astronauts, because like with every astronaut that actually lands on the moon, there's hundreds that have gone through like experiments, that have gone to space, that like have gone through rigorous training, that completely believe in this so-called lie, right? And so like across the globe, not just within the U.S. Even if like, so it, like this wasn't just a U.S. conspiracy. So you're saying not one of them would have like ever considered telling the supposed truth? Like,
so whistleblowers is what you're talking about, right?
Yeah. So
whistleblowers did exist at the beginning of NASA. Again, this is just stories, but this is the history behind when NASA was established in the early 1950s, I believe. When that was happening, there was astronauts that basically were going to come out and basically say that it's impossible to go to space, and basically it's preposterous. So
yeah,
there
people said that about flying too.
No, but what happened with this astronauts, they just completely they died in accidents, right? So they were just basically replaced. So the astronauts that were gonna basically blow the whistle that's impossible, it's physically impossible, it defies physics, they were basically removed. You know? Again, they were killed in an accident at NASA's facilities, but
and so like, well, I'm just wondering like the evidence like regarding that claim.
Again, I would say those are just stories. The evidence is with physics, so understanding how water behaves. So exactly.
But then going back to like what I'm saying before is that like if you're saying the evidence is with physics, doesn't this like go against like thousands of years of like foundations of physics, of not just like from NASA itself, but even going back to like Galileo and like the Greek philosophers were like they're calculating the Earth's curvature and they're calculating the Earth's radius. Like this is not just one like recent phenomenon. It's like years, thousands of years, hundreds of years of history.
So I would say all of those scientific experiments that you're talking about that were supposedly conducted to prove that it was a globe, right? All of those, I would say they're just stories. They're not being backed up by the practical experiments. So you hear about, for example, the shadows and sticks experiments by, I think it was, what was it name? Aristophanes, I think, or something like that. Point being, the sticks and shadows experiments, have you ever heard of that? Somebody put a stick on the floor and they measure the shadow, and that's how they supposedly measure the curvature of the Earth. That was, I think, done 2,000 years ago. Point being is that experiment of measuring shadows and the length it changes based on the sun's positions is based on the assumption that the Earth is a ball already. So they're not measuring for the curvature. They're assuming the Earth is a ball already, and they're basically assuming the radius based on the angle change.
But then, like, so even before that, like the common held opinion was that the Earth is flat before like scientific innovation, before all of that, and so they always operated under that like presumption, right? So, through that, they eventually discovered like the inaccuracies. Like in the same way we've kind of progressed throughout science. No, if like we used to believe that the Earth was the center of the universe, that was the held belief, and then through science, like through physics, whatever it may be, like we debunked those beliefs and we moved on, right? So like, I feel like your reasoning, like to kind of
going backwards. You think I'm going backwards?
Yeah, I mean, I feel like almost like.
You could take that with you if you, So, let me just go backward there real quick. So, they tell us that, back then people believed the Earth was flat. In my opinion, people understood there was a level plane. I wouldn't say it's flat because flat has nothing to do with orientation. So, flat Earth is a psyop. Over 95% of flat earthers, proclaimed flat earthers, believe the Earth is motionless. Which again, flat has nothing to do with orientation. And Earth does have orientations. And in order for something to have orientation, it needs to have direction. And in order for something to have direction, it needs to have motion. So the Earth is in motion, pushing up against us. So that's what gravity is. Gravity is a pushing force, not a pulling force. So have you heard of gravity being a theory when pulling objects to the ground? Have you heard of gravity, right? Being a pulling force?
So
the fact is, this is the Earth that's pushing up against us.
So my next question would be like,
sure.
And this is kind of like a different topic discussion in a sense, but like,
sure.
So if the Earth is flat, does this also mean that, like, say, Mars is flat and Moon is flat? And Sun is
so let me ask you this: you know what a rainbow is, right? Mm-hmm. Could you walk on a rainbow?
No.
Why can't you walk on a rainbow?
Because it's not like a physical thing.
It's not solid, right?
Yeah.
It's just light, right? So if you've ever seen the stars with a telescope, for example, this is what the stars actually look like. So they're just twinkling lights in the sky. Nobody actually knows what they are, and they're definitely not solid. So these are the planets. Again, no different. The only difference with the planets and the stars is that these have their own unique paths. Oh man, no worries, man. Yeah, no worries, man. So basically, it comes down when it comes to the stars and the planets, what's up above in the sky. I would say that's a red herring. It's a false argument when it comes to establishing the dimensions of the ground we stand on. So again, the lights in the sky, nobody knows what they actually are, but it's just lights. And I don't know if you knew, when you elevate at a certain height, they actually disappear. So there's just a visible phenomenon. You know, nobody actually knows what they are.
I mean, so like, I'm just wondering, like, so like we have like telescopic images of it.
I would say,
right?
yeah, this is what they show as a cartoon version of what the actual is. This is what it actually looks like. And again, same thing with Mars. This is what it actually looks like, but this is what they show as a cartoon.
Well, I mean, could it also just be because you're like not using an actual like high? I mean, like
a $1 billion camera
I mean, like,
that nobody else can afford.
Even like amateur
telescopes, they will see this. Yeah, telescopes all see this. But they tell people, oh, you see light because, you know, it's traveling.
But there's like thousands of like people that either build their own telescopes for their backyard or like regardless, and they're able to capture like high quality photos of like the planets that like correlate with what.
I would say those high quality photos are CGI.
Even if they're like amateur people just doing it, like you're saying, like hundreds of different people from across, like not hundreds, thousands of different people from across the globe are like building their own telescopes and then feeding into a lab.
And basically, all these expensive telescopes that show us supposedly these images are there so that, again, they have to be really expensive telescopes that nobody can afford, because that's how they're able to feed us the information they want without us double checking it. Does that make sense? So if I was to ask you just real quick, because we're jumping ahead, what's the number one proof that convinces you that the Earth is evolved when it comes to physically and practically? What's the number one proof or experiment?
I mean, I'd say there's a lot of them. I couldn't name one like definite one on top of my head, but I will say, like, if you're just like, I don't know, looking at sea and you see a ship just sailing, eventually it's going to slowly disappear over the horizon because there's a boat and it's like falling from view.
Well, it surprised you to know that once you think it disappears over the curve, when you bring out a camera, the same camera to zoom into these stars, when you zoom into the boat, it comes back into view. So it basically just goes out of perspective. So we do have a limit to how far we can see. We have spherical vision because we have spherical eyes. So parallel lines do intersect in our field of view eventually. So that's the limit of perspective, which I would call the horizon.
Wait, so I mean, you're just saying if you have a powerful enough telescope, then we'll see
the boat in view again.
Okay, so then
it's just going out of sight. That's why.
Like, say you're at, I don't know, like the top of like the mountain, right? Like a tall mountain. So with the tall enough telescope, you're saying we could see the entirety of.
No, so you would need an infinite zoom telescope first of all. Just even telescopes have a limit. They only have 20 times, 40 times, 8, and there's no such thing as an infinite zoom telescope, right? Would you agree on that?
Okay, wait. So sorry, like you see, there is no such thing, but then would you also like agree that there is such thing as like microscopes that can zoom into like?
Sure, but even that there's a limit too. How far you can zoom in.
We can go to literal like atoms.
Sure.
Would you believe that?
Atoms. Well, atoms. I would say that's when it comes conceptual. You know, I don't know if you knew, atoms have never been proven physically. They're just
they have though. But like for example, like quarks, gluons, whatever, like those subatomic particles, maybe. But that's just if light travels, like literally, like the presence of light physically disrupts like that appearance, and so we can't accurately give a depiction of those. But atoms are big enough for us to like perceive and measure, even sometimes like like have single
Yeah.
atom layers of like graphene polymers or whatever. It is,
Okay,
right?
sure. So when it comes to telescopes, okay, even if let's say we did have a camera that could zoom very far, right? We still have the atmosphere, which is gonna neglect you from seeing so far. So let's say if you're in water, obviously the thickness and the fogginess of the water, you can't see forever. You know, eventually, you know, it becomes too thick to see through. Same thing with the atmosphere because of the, you know, the
So like it's like on a clear day though, like
even on a clear day, you're gonna have perspective issues, and you're still gonna have the atmosphere. Again, the further you're observing through more layers and layers of atmosphere, you could call it, the more thicker, you know, you're not gonna be able to see through it. It's like if you put glass, a bunch of glass in front of each other, eventually, you know, if they're a little foggy, you won't be able to see through all of them. Would you agree with that, or?
I mean, I feel like it's a lot of different excuses, or sorry, different like reasoning that it's just built up to, like.
Well, it's simply perspective. We just don't see forever. That's a fact. Would you agree or disagree with that? We don't see forever.
Of course.
Yeah,
But
we
what
don't
I'm
have
saying is
infinite
that
vision.
We have the technology in the same way we have the technology to get down to just infinitesimal particles
Sure.
that we are made up of trillions of like quadrillions of them, like under like literally atoms. They're so tiny.
Right.
Like, why would we not have the same technology to perceive as far? Like in the same scope. Like I feel like why is that the barrier when like microscopes aren't the barrier? Or like why that's the barrier when like radiology isn't the barrier?
Well, it's not the barrier. I would say the atmosphere is a huge factor. I would say the atmosphere has more of a factor than just being able to zoom in, you know, long
I know, but
distances.
then like if the atmosphere is such a big factor, then how come we can get these images of
Because
space?
we're pointing up. We're not, again, the thickest
Exactly.
atmosphere is at the closest to the Earth. Would you agree or
Yeah,
disagree?
but like,
yeah.
wouldn't that atmosphere also be covering up us if we're like just looking up? Like the atmosphere is still there regardless.
Yeah, but what I'm saying is when you're looking up, it's not as thick as when you're looking straight on ahead. So obviously, and another thing about the stars, they're not trillions and trillions of light years away like they're telling us. We wouldn't be able to zoom in, like you're right. We wouldn't be able to zoom. They're actually, in my opinion, they're very close. And I would say Earth does have kind of a ceiling because it has to be contained. The Earth is a contained system. Have you heard of the second law of thermodynamics? So it's when high pressure moves to the lower pressure unless there's a solid barrier between them.
Wait, is that?
Yeah, second law of thermodynamics. It has to do with entropy. You can look up entropy.
Yeah, I thought it was entropy, but
Yeah.
not necessarily high pressure.
Yeah, high pressure always move, hot always move to the cold. It has to do with equilibrium of pressure. Unless you have solid barriers separating the two pressure systems. So outer space is only a concept because it defies that law of physics. You can't have an open Earth system next to a vacuum. It will suck all of the atmosphere out. But their excuse is, or their explanation is gravity, a pulling force, again, imaginary force, is holding the air in. So apparently this force is the container.
So like, why would you say gravity is an imaginary force?
Because when you release an object, even the mainstream admits that there is no force acting on it to pull it down.
Gravity
Yeah.
is the force.
But I don't know if you heard of Einstein's theory of relativity, the modern theory of relativity. He accounts for that fact that when you release anything and it's in free fall, it's free from any force. That's why it's called a free body, free fall.
No, it's still like, would you not say that the force of like air resistance is impacting it, the force of gravity?
Yeah, the air resistant force is there. I agree. But when the object is being accelerated down, the force is actually up again because of air resistance. When you let a helium balloon go,
So
what direction
happens?
does it go?
Why does it go down?
Well, because when you let a helium balloon go, what's happening there? What do you think?
Because
Why does it go up?
The helium gas is less dense than the air around it.
The air pushes the helium up. Did you know that?
Well, I mean, it's just density, like you said. Like
Yeah.
just,
But buoyancy
rises.
is a push. It's a pushing force. It's an upwards thrust. I don't know if you knew that.
Okay, sure.
So the air is pushing on the helium because it's less dense. Is this more dense or less dense than the air?
More dense.
So can the air push this up?
But like in the sense where like if you have like a feather, right, and then it's falling.
It's trying to push it up. That's why it goes down like this.
Yeah, but like the idea of like if you were, I mean, the famous experiment of like I think it was like literally like Leaning Tower of Pisa of like dropping something with like a tiny weight, something with like massive weight, and then falls the same speed and lands like.
That's only in a vacuum. They did
Exactly.
that. Yeah, in a
And so
vacuum.
air resistance force. But the thing is, like, what I'm trying to say is,
Because the force
you
is
can't
up.
see air resistance in the same way you can't see gravity. So how do you know air resistance is there but gravity isn't?
Well, air resistance can be measured through buoyancy. That's my
So
point.
gravity.
That's my thing. Even Einstein admits that they have never measured gravity. That's why it's still a theory. It's not even up for debate. You could look that up.
Okay, so like,
Yeah,
sorry,
gravity
sorry,
is a
yeah,
theory.
listen, what
Gravity
should I
as a
say?
pulling force is only a theory. Yeah, you could put gravity, or you
So,
could
like,
put
is
Einstein.
gravity a theory?
Yeah. Oh, actually, I could could show you a video. You could look this up. Why gravity's not a force on YouTube. Have you heard of the channel Veritism? Veritism? That video has like 14 million views, and they basically admit that gravity is not a force pulling anything down, and it's the Earth that's moving up. But that's where Einstein's theory of relativity comes in, kind of to explain it from a globe perspective, you know.
Wait, so I'm just wondering, like,
Sure.
you mentioned like Veritism, and like you're accepting this guy's like.
No, he's just a mainstream channel that acknowledges Einstein's theory of relativity. So even the mainstream admits that there's no force pulling anything down.
But then at the same time, he's also like a supposed round Earth believer, and he agrees with most other like modern conceptual ideas.
You want another explanation from a globe perspective? It sounds ridiculous, but I'll try to simplify it. So they acknowledge that the Earth is pressing up against us, and it's not this that accelerates down, right? So from a glober's perspective, that wouldn't work, because if the Earth is pressing up against our feet and it's not the object, that would mean the Earth has to be expanding in all directions. It has to be growing, right? That's retarded. That obviously.
No, because gravity pulls it back. That's the thing.
So their explanation is that Earth, apparently, it warps space. So that warping of space that it creates by existing, it's basically sinking itself to its own. In its own, I guess it's in the own space that Earth warps. It's basically trying to sink into itself, but the Earth is supposedly accelerating up, so it cancels that bending and warping of space-time. So that's why it's pushing up, but without moving. That's from a globe.
Like expert on like, I don't know, just like physics in general, but like I feel like
the fact
going back to other ideas, because like I can't really like debate on ideas of like physics, because I'm not as well versed as I guess you purport to be. But like in terms of just like logical reasoning, like I feel like you're almost picking and choosing like data from people that do believe that the Earth is round.
Well, if we're talking about logic and reason, what logic and reason would you have to offer to me that the Earth is a globe? Let's talk about logic and reason.
Sure, yeah. Like one more time, just like the idea that like every single person that has ever.
So it's a consensus thing, just because everybody believes it. And I wouldn't say that's very logical.
Hi, how's it going?
Hey, how's it going?
I'm just kind of curious what's going on, if you don't mind interrupting anything.
Here, you could give it a read. This is what I'm doing.
Trying to convince me on flat Earth. Or like just we're talking about the idea.
Yeah. Well, flat Earth, I would say, again, the Earth is not flat, because flat has nothing to do with orientation, and the Earth does have orientation. So the Earth is level.
It's not a globe, though.
It's not a globe, 100%. It's level. Level relative to the motion vector, which is the vertical. So the Earth, again, it's a level plane, but it's actually moving like this. So it's pressing up against your feet right now. That's what gives you weight. So when you release an object, again, the phone's not dense, it's more dense in the air, so the air that's being pushed by the ground can't push it up. So that's why it appears to go down or accelerate now, but it doesn't. It's the Earth and everything else that's connected to the Earth that's moving up.
And then, sorry, going back to what you're saying is like the idea of like when you talk about like the idea that every single, I don't know, like almost every scientist that has, I don't know, ever worked, like all of them are colluding to.
They have to be. I mean, that's not. I mean, I would say a lot of them will just believe what they're told. Again, a lot of these people just go to an office job. They work behind a computer, and they just get paid and
but
go home.
A lot of them also do experiments to like prove and like reaffirm these ideas.
I would say these experiments you're talking about, I would say these are just explanations or data entry of what they're being told. It's not a physical experiment of measuring, for example, a physical curvature.
But they do, though. Like in the same sense, like once again, like even like you agree that like even Greek like scientists or whatever, like they found ways to measure like.
Well, I would say they were assuming there was a globe, and they were measuring for the circumference.
But they weren't, though, because like they previously had never like known it was a globe. The only thing they could like visually see was that it was flat. So they made experiments, and then they realized through their experiments.
What experiments were those? I guess I might have missed them. I might have missed them. I've been doing this for 8 years, so I might have missed those experiments.
Yeah.
I mean, can you recite one?
I mean, I can't off the top of memory, but I'm down to look one up right now.
Sure, you could look one up. Again, you could actually take my flyer as well. So my YouTube's here, and my email's on my YouTube. So you can email me something too if you come up with, if you come across something when you leave, and you can send me a message, an email, and I'll definitely highlight it in the next video and stuff. But yeah. So let me ask you this: how open are you to the idea that maybe we have been lied to? Or are you 100% convinced that it's a ball? Or are you open to the idea that maybe we have been lied to about the?
I mean, I think it's like almost like a misnomer to like say, like, for example, it's like how open am I to the idea that like everything we're living in is like a simulation or like in the Matrix. It's like until like there's actual concrete solid evidence for that, then I'm open to believe it. But the problem is like I myself have never seen.
That's where a physical measurement of water comes in. You don't have to believe it. You have to just understand it. That's why water is very important when it comes to this subject. It's probably the #1 proof that debunks the globe. There is another proof that debunks the globe. Again, the fact that objects don't accelerate in free fall.
But they do accelerate though. Like an object, like for example, like if you were to drop like this, and then if you were to drop that, like say, I don't know, 100 feet in the air, it would go faster.
Yeah, so there is a change of rate, I agree, per second. I would say that change of, it's deceleration. So if the Earth, again, the Earth is in constant motion. Exactly. So if the Earth is in constant motion right now, hypothetically, let's say it's going 1,000 miles an hour, right? If I'm holding this and I'm attached to the Earth, which also, we're all, it's all moving, as soon as I release this, it's going to start to decelerate. So it's going to start to lose momentum. Therefore, the change in speed from the constant of the motion of the Earth relative to this, as it's losing momentum, it's going to appear like it's accelerating down, but because it's decelerating.
No.
That change of rate, it's a deceleration.
So then, like, how can you call it a deceleration when it is getting faster, though?
No. To us, because we're inside the Earth's reference frame.
It's relative.
So let's say there's a car in front of you, and you're behind the car, and you're both going 100 miles an hour, right?
Yeah.
When you release the gas on the car in front of you, what's going to happen? You're going to hit it, right? Eventually, right? Is that a fact? Yeah. So what happens? This didn't go down, did it? The car in front of you didn't go in reverse. It's just slowing down, and you eventually catch up to it. That's kind of like what's happening here. When you release it, it's not going down, it's just slowing down, and the Earth just catches up to it.
But like, what I'm saying is like, if you're doing that same like car idea, would a better version not to be like you guys are both going at 100 miles per hour, and then you release a ball inside the car?
No, I know what you're talking about. Because
that would be more akin to what like the Earth is.
Well, the size of the Earth is not the size of a car, so scale has a lot to do with it. Because again, we don't know the exact speed of the Earth. All we know that is
in your own experiment, though. Like, why does the size of the Earth is not the same thing as the size of the car? Why does that not also apply?
So when you release a ball, for example, within the car, and you release the gas, you're familiar with inertia, right?
Yeah.
Inertia being that there's no force acting on something anymore, but it's still moving, right? Well, I would say,
once again, like the force in this case would be gravity.
But that's my point, that it's not the object moving towards the ground, it's the Earth and everything that's attached to it that's moving and catching up to the object once you release it.
Are you saying we only have vertical motion going upwards?
Yes. That force is up. That's the fact.
So
that's why buoyancy, helium balloons go up and air bubbles go up in water. That shows you the direction of the force.
No, but the reason why, like we talked about before, is because like changes in like density, like the high pressure versus like low pressure areas, like that's what causes it to go up. No?
Did you know that? Yeah, you can have pressure within a medium, like a fluid, for example, without motion. That's another thing. So when you release an object into free fall, all the pressure within this container vanishes as soon as I release it.
What do you mean?
So for example, if I have holes, I can show you. Look.
Oh yeah. You mean like the water doesn't like stop spilling?
Exactly, because there's no force in the container when it's in free fall.
No. But like the reason because of that is because like they're all moving down at the same rate, and but that proves my point.
No. So now you're getting into imaginary forces that can accelerate all states of matter without displacement. So what that means is, for example, if I have this water bottle, right, and I accelerate it this way, right, you see displacement, right? The water moves, right? You see that? That's acceleration. The water reacts to acceleration. Would you agree, right? So when we're talking about free fall and acceleration down, there's a huge difference here. I'll show you.
I mean, isn't it just because there is no like horizontal gravity? Like gravity is acting like downwards on us. It's a downwards force.
So, for example, look at which one would you say is accelerating from these two?
What do you mean by accelerating?
Which one's accelerating?
Like moving.
Which one's displacing? Which one's showing you displacement?
Displacement?
The one on the right, right?
The one on the right.
Because I'm actually physically accelerating that one down with my hand. This one on the left is just in free fall, but there is no displacement. There's no reaction to that acceleration because the water will always move to the back of acceleration, pushing the air towards the front of acceleration. So this is a simple accelerometer. As soon as I accelerate this that way, the air gets pushed to the front. Look at that. And the water moves to the back. If I go that way, you get the opposite.
I'm not scientifically literate enough to like understand.
It's a very simple accelerometer, having air and water in a bottle and accelerating it. That shows you the direction of acceleration. It's a simple accelerometer.
What I'm trying to say is like, when you drop it in free fall, the reason why it doesn't move is because everything is going down at the same.
So you believe that there's a way that I can accelerate this without displacement. So you know how the water's level like this?
Yeah.
You think it's possible to accelerate this in any direction with staying level?
Not any direction, only downwards.
Why?
That's where gravity
And
is.
I would say that's where what was the word? I would say that's where you're special pleading for a special force that cannot be recreated.
What do you mean can't be? Like,
So a force that can accelerate a solid, a bottle, a liquid, and a gas without displacement in any direction doesn't exist. So I can't accelerate this without the displacement. It doesn't exist. The water's always going to react through acceleration, right? But if you believe in gravity, this is a special pleading. Well, not in free fall. You see, it doesn't displace. But again, the reason why it doesn't displace is because it's not accelerating.
Wait, I
It's a
still
special
can't wrap
pleading.
my mind around like this whole idea of not believing in gravity. Like this is once again has been like a phenomenon documented throughout history of like people didn't believe in gravity and then like post Newton started to believe like experiments were done in order to like prove this idea. Prove this, like,
Yeah, on YouTube, look up the video called "Why Gravity Is Not a Force." Again, Veritism. He explains it completely. That's what I'm saying. Like, it's not even up for debate that it's not that
he
gravity.
also believes in gravity.
Yeah, he does.
Yeah,
so
and he believes in the Earth.
Yeah, I would say his mind is twisted.
So then how can you like pick and choose what he believes as like fact and then also at the same time
No.
say
I'm not saying
everything
it's
else
fact. I'm just saying they acknowledge the fact that there's no acceleration.
But
now.
then like
They're not the ones. I'm not believing that because they say so.
But you're only
I'm
choosing-
acknowledging that they're acknowledging it.
yeah, but you're only choosing one supposed fact to acknowledge. Like you're not acknowledging everything else he says.
No, I'm acknowledging. Well, yeah, because everything else is bullshit. The fact that there's no acceleration in free fall, that can be demonstrated and proved. So you know an accelerometer, for example, and your phone has an accelerometer. You could download an app called, I forgot what it's called, but you could download an accelerometer app on your phone. It detects acceleration in all directions. So if you have your phone holding it steady and you accelerate it any direction, left, right, up, down, it's going to detect all that motion, right? In free fall, guess what it detects? Zero acceleration. So even accelerometers show that there's no acceleration when they're in free fall. You know? There's a reason why speedometers, like police radar guns that detect speed, they cannot measure the speed of something falling. I don't know if you knew that.
I mean, but like
Because they're not accelerating down, that's why.
the thing is like I mean here.
Sure. I mean, if you have something...
I'm down to like download an accelerometer app.
Sure.
And like once again, like I can't really, I guess, adequately debate on like ideas like science because I guess I'm not as well researched as you are.
Sure.
But
I
like
understand.
going back to this idea of like logic, like if you want to talk about like the original like Greek,
Philosophers.
yeah, or like I don't know, just like general ideas of like. I don't know. I guess I'd like to ask your thoughts on like an eclipse per se.
Sure. So I would say, again, when it comes to the luminaries and what's in the sky, I would say you can only have ideas about that. And I would say ideas have nothing to do with physics, because physics is what it is. Yeah, you could see it, but we don't know what's actually happening, because we can't go there 3-dimensionally and go around them to prove, okay, this is what's going on.
Like using like say telescopes or whatever, like you can make scientific.
Want to take one with you?
What is this? Sorry.
Yeah, it's okay. So you can read it.
Don't worry,
You can read it. But yeah, I would say again, when it comes to the stars and the luminaries in the sky, it's just storytelling. Nobody knows what they are. That's my point. So if I give you my opinion on them, it's just gonna be my imagination when it comes to the sky. And
But,
nothing.
like, at the same time, like nobody knows like what's happening in atoms or whatever. Yet we use like scientific instruments in order to find out like what that is, and like we use that like technology in order to like be able to harness that power of like being able to like inject like for example like the entire like ideas behind radiology, behind whatever that is,
Yeah.
uses these ideas of what we previously couldn't have imagined. We could just theorize,
Right.
but from those theories develop technologies in order to prove it. Like
Theories, in my opinion, following up on that, have to be attached to physics in order to invent something, right? Because if you're just theorizing about things that are not attached to reality, like flying elephants and flying pigs, like you're never going to achieve that.
But like a scientific
mutating.
theory doesn't mean just like something that anybody could create. A scientific theory is something that's backed by like,
Physics, exactly.
Exactly, yeah.
So that's the thing. The globe is not backed by physics. It's just backed by stories. That's where most people don't understand. They think it's backed by physics, but it's just storytelling about
And
physics.
like,
So they're claiming it's physics, but it's just stories.
it just once again like
Yeah.
I feel like cherry picking a single supposed theory to like most of scientific literature is theories, but these theories have been like abundantly been proven by.
Well, they wouldn't be theories, right? If they're been proven.
No, because once again like here
You could take that with you.
I'll just.
No, it's
If you want to
okay.
add something,
Okay,
feel free
sure.
to. Feel free to add it.
No, if you have any
No,
questions about
I
it.
mean, I don't have questions. I'm kind of dumb. I don't understand all this physics
Trust me,
stuff.
you're not dumb, but
But I saw the back of this, and this is kind of like faulty reasoning, because it's like saying that like if I were to stand here, I would be
horizon
able
should
to
never.
see.
Yeah. So if they're telling us that we're always standing on top of a ball, right?
Yeah.
So if we're standing on top of a ball that's curving down supposedly, so if we're standing on top of a hill, for example, right, on top of a hill, will the end of the hill ever rise to in front of you?
Well, this diagram and your reasoning, the Earth is way too big. We
Yeah,
would
I
never
know you're
stand
talking about the scale
at
there.
that height.
Even if I zoomed in though, and if somebody's standing on top of it, the ground should never rise up to your eye level.
Yes,
That's
it would,
the point.
because the
Because
slope
there's always
is too
gonna be
big for
more,
us
like,
to
mountains and
notice.
more hills.
No, you're not saying. So geometrically, if we're always standing on top of a ball, for example, right? We're standing on top of a ball right here, right? And we're looking straight out into space, right? Into the sky, right? When we elevate up, for example, the horizon should never, or the ground should never rise up to your eye level, like right here. You should never see the ground right here when you elevate up, right? Geometrically. But this is images of the horizon 20 miles in the sky, and the horizon, again, the ground appears to rise with you, because again, the horizon is only an apparent thing. It's only the limit of
So
perspective.
one more time, like I'm wondering, like you before said that like you physically couldn't get this high. You said this wasn't possible.
20 miles is the limit. They can't go high enough to take a picture of the whole Earth as a ball. That's my point. This is as high as they could go, and this is what the horizon looks like. Yeah, they can leave low Earth orbit, which contradicts the claim that they went to the moon in 1972, 1969. You know. So again, the globe Earth has contradictions left, right, and center. You know. Again, in the only place you see curvature again is to CGI images like this or GoPros that serve horizontal lines. So you're familiar with the wide angle lens, right? The fisheye lens.
Mm-hmm.
Yeah, that's the tricks they use when you fly up above.
One second, sorry.
Sure.
I have to go soon, but just one more.
Thing, yeah.
Sorry, no. This is for we were talking about earlier
Right.
about like the Greek scientists. I kind of forgot to go back to this.
Sure.
Of like. So.
Okay, there's Aristophanes.
Yeah. So, yeah, like these
Measure
are
the angle of the
experiments
sun.
that they had like nowhere near the level of technology that we did,
Right.
and nowhere near the level of like I don't know, like why would they be in some sort of cohorts to like I don't know, trick the world?
So again, it comes back to control. So if they could get you to trust these authority figures, right, and make you believe that they're smarter than you, then most likely you're gonna follow them when it comes to creating a society, for example, right? Like you're gonna go and basically obey and just be, you know, what you're told from these experts because you believe they're smarter than you and they're looking out for you.
Would
Right?
it not be the opposite? Because like, for example, like Galileo was in prison, and I don't know, I forgot if he was put to death or not, but for specifically refuting like heliocentric ideas and like, so he was doing the exact opposite.
I would say that's reverse psychology. So yeah, they tell us these stories that the opposite happened. So, you know, so somebody that didn't want to, you know, that went against the globe, what's all you're saying, right? They went against the heliocentric model.
I mean, yeah, and also just like ideas of like flat Earth, like this was like universally like unpopular when
Right.
he first proposed it,
Right.
and yet he still decided to because like
Right.
he knew this was backed by like logic and reason, and so decided to like continue on with his beliefs and.
Right.
Was
Well,
persecuted for it.
again, when we're talking about history, again, it's just his story. It's just a story at the end of the day. If we can't reproduce or recreate the experiments they did back then it's useless when it comes to physics.
But people have.
So
For
this
centuries later,
So
people
yeah,
have.
so this experiment, again, they measure the angle. Two assumptions they did. They assumed that the Earth is a globe already.
No.
And they assumed that the sun is 93 million miles away, so that the sun rays are coming in parallel, so that the angle of change. So they admit they
I'm just wondering like how they would find out 93 million. Like these are Greek.
that's why I asked. How did they come up with that 93 million mile
Where does
sun
it
distance?
talk about 93 million? Because like all he talks about is the idea of what a circle is,
Yeah.
and that's all. Like there's no reference to any sun. Like
And I'm glad you said the idea of a circle and what the degrees would be if it's a circle. based on these shadows. Again, you have to assume that the sun rays of the sun are coming in parallel as well.
He didn't talk about the sun.
No. Well, if you look up at the full experiment, they have to assume that the lights are coming in parallel.
Okay,
That's part of the experiment.
I just for example,
Yeah.
if you assume that 2 + 2 is 4, and then you do 2 + 2 is 4.
I wouldn't say
Then
that's an
there's something
assumption.
wrong.
I would say that's a simple fact. 2 + 2 is 4, right? Based on the language we created.
Yeah. But okay, if you assume that.
But you could assume that I have a pink elephant in my garage and it weighs 600 pounds, but you've never seen it. You can assume that, right? You never
But
confirmed
you
it.
do experiments to prove it, and then you prove it to be false, and then you disrepute, then you refute
Yeah.
that. But in these cases, they assumed something,
and they never proved it.
They did.
They never. How did they prove 93 million miles or the sun rays are coming in parallel?
That's the thing, is he didn't need that. He didn't need that to.
Well, how can you measure angles if the sun rays are coming in at different angles? They have to be coming in at the same angle to be able to measure angles from shadows. They have to be. That experiment will be false if it didn't. If all the angles of the sun are coming in at different angles, then how can you measure angles at different distances on Earth?
Relatively to the sun, he did this experiment between two cities. The specific angle at which the sun is coming in.
It was coming in. They said that it's coming in at the same angle at both of those cities. So the change in shadow from those two cities is theoretically telling them. Yeah. Again, they have to assume that the light's coming in parallel from the sun. Because the sun's very small and local. And have you ever seen crepuscular rays, actually? Oh, here they are. Crepuscular rays literally show you that the sun is very small and local. They're coming in.
This is from light diffusion through clouds. This is
Okay, I've heard that before, but again, the parallel light, again, coming in, hitting the Earth is a must, which is an assumption
so then,
for that experiment.
If these crepuscular rays, then would it not just be this area of the Earth being illuminated with sun and everything else being dark?
Well, it does illuminate 360 degrees too. So it illuminates this way too. So as far as the light could reach.
But then that shows that rays going like this.
Yes.
That's never going to hit the Earth. So this proves that the Earth is
No. They say you have a street light, right? It's above like that street light, and we had a perfectly level surface out of it. When you move away from that street light, eventually it's gonna appear to go down in your field of view. To apparently it disappears behind the horizon.
No, and eventually the street light just stops because
look, for example, here they are. Look, eventually, if you keep going, are you gonna be able to see the? Let's say we had 1,000 of these lined up. Would you be able to see the last 100 of them?
That's crazy in the shining, but
you know what I'm saying? So perspective limits us from seeing the sunlight all across the Earth. So again, perspective. But we know these lights are not getting short. It's just perspective. Everything shrinks in our field of view to a point. And that's what.
What you're saying is that if you had a strong enough telescope and if the sky was clear, you could just see from one end to the other.
Yes, theoretically, yes. If there was no atmosphere whatsoever.
And so, this is a whole other topic discussion that I probably don't have time for it, but I'd love to talk about.
Sure.
It's so where are these ends of the Earth?
Oh, I'm glad you brought that up.
So a lot of ice wall around Antarctica?
So a lot of people like to strawman and say, oh, where's the edge of the Earth, right? So a lot of people think the Earth is like a disk just floating in space. But again, I don't accept outer space as an environment that exists. It's just fairy tale. So the Earth is a contained system and it's moving. What's outside of it? I have no clue. Some people think it's water outside of it.
What's at the edge of the containment?
Well, that's the thing. If there is an edge, it's just the end, I would say. It's what this container looks like. I don't know. It has to be a solid container.
So if someone were just to go
straight, you'll find it. I don't know if you knew there's an Antarctic Treaty. Have you heard of the Antarctic Treaty? It prevents any private explorers from actually exploring this place. So
if you were did have to get there first.
Well,
to discover Antarctica.
I would say government did get there first, and they basically shut it down for anybody else to explore.
Okay, so then alternatively, how about the Arctic? So what's
the North?
Arctic?
Yeah, so the North is actually even more restricted than the South. I don't know if you knew that.
Once again, people had to get there first.
The government. And who's to say? Maybe there is other civilizations that live there. Who knows? I don't know. What's at the North? What's creating this magnetic pull for real? I don't know. Flat Earthers claim it's a mountain, but I would say that's bullshit.
Wait, so if you're not a flat earther, what would you report yourself to?
I'm a realist, if any. If I had to say a word, a realist. I just go with...
What would your model of Earth be?
I don't have a model. A realist doesn't have a model. Because the Earth, again, we don't know the full dimensions of the Earth. That's one of the facts. So a lot of these flat earthers...
So you're saying there's never going to ever be an experiment?
There could be. We could explore this space and maybe find out the full dimensions of it, but it has to be done at a mass scale, not just putting government to do it for us, because they're going to lie.
That's the thing, though, is that they haven't been government. there's been like
Well, church, it was before government. I would say government is a church, just in that.
Church was the one that like propagated a flat Earth model, like heliocentric model, like, or sorry, like they were the ones that persecuted Galileo. In a sense, like,
yeah, sure.
Like Galileo, like, was the independent. He was, in a pure sense, like the contrarian. He was the realist, whatever it may be.
Sure.
And his findings ended up like revolutionizing the way we think about the world.
Right.
Generations, and this has been proven by independent researchers, like people building telescopes in their own backyard, people doing their own experiments around where we like millions of people across the globe with scientific curiosity have been able to make these discoveries by themselves, and yet all of them have decided to trick us.
So what, again, you're talking about all these discoveries and all these experiments, but what experiment did they do? What discoveries did they
I don't
find?
know.
Oh, so you're just speculating that they did. You're just assuming that they did, right? I would assume.
They are doing this. Like
Okay, if they are doing it, can you tell me which? This is where.
I'm so sorry. I'm not as prepared with the whole document.
So that's what I'm saying. Right now, it's
briefcase
just an
and
assumption
language.
because you don't know.
Well,
So it's safe to say right now, you saying all that is just an assumption because you don't know the actual experiments.
Like,
You're assuming that they
in
did,
the same
right?
way, like would you believe like cancer to be an assumption? Would you believe like red blood cells are an assumption? Like you've never seen these for yourself.
Sure.
You've never seen microscopic like atoms by yourself, and yet
I would say I don't know, but you're saying you do know. I would say that you should say you don't know that.
I'm
Because
saying
I would say
can
I don't know.
trust science.
So you trust these people. That's what I'm getting to. So you assume, you trust that they're telling the truth.
In the same way you trust like that, like
I trust my senses. That's what I'm saying in physics.
like so like have you ever seen like an elephant in real life? Or like
Yeah,
a
I've seen
flamingo
an
in real life?
elephant. Yeah.
Or like penguins, or like I don't know, Black Panther.
Yeah.
Seen like,
I haven't seen them in every animal in real life.
do you trust they exist?
That's the thing. It could be CGI on TV, right? Not until I experience it for myself, then I can say 100% yes.
But the fact is that so many other people have seen it.
Sure.
And so
I'll
then
accept that. Okay, maybe they do exist. There's a high probability that yes, they might 90%.
there's a high probability.
But because I haven't
100%.
experienced it myself, I cannot say 100%, right? But I would say 99% sure.
And
But
see,
it's
that's
still
what I'm saying, is that I can say 99% sure.
but
because
but I can experience
hundreds of years of
Sure, but
history
yeah.
and millions of people across the globe and multiple national organizations have all experienced this. So I can say with 99%, if not 100% certainty, that this is true.
So okay, let me ask you this: flying reindeer, Santa Claus.
I'm
Do you?
so sorry.
Okay, man.
I have to go, but
No worries, man.
Thank you for the conversation.
Yeah, no worries, man.
Okay,
Take care.
and I'll be sure to look up your YouTube
Yeah,
channel.
definitely, man. Appreciate
Are
that.
you going to be tabling here in other weeks, or is it just
It's not the first time I'm here. I've been here more than 10 times. I do come here maybe like once every 2 weeks, you know. I do post up here or sometimes next to the tower inside, like in that area. Those are the two places I do post, and I do it every other week. So you're around this time too, so if you want to catch me again.
One more time, what's your name?
My name's William.
Nice to meet you.
William, man. Nice to meet you too, man. Thanks for the chat.
Of course. Have a good
Appreciate
day,
it.
man.
You too, man.